Welcome to lesson 11. In this lesson, we will be looking at right triangle trigonometry. Okay, we have two objectives for this lesson. Number one, given some information about a right triangle, finding trigonometric ratios. And our second objective is to use the given trig ratios or trig values to solve a triangle, rather a right triangle in this video. What does it mean to solve a triangle? It means to find the missing sides and angles. Let's recall the 6 trigonometric ratios or 6 trigonometric functions we've already seen. Okay, let's look at our angle theta. Sine theta was defined as opposite over hypotenuse. So for this triangle, it would be 5/13. Cosecant was the reciprocal of sine, so cosecant theta would be this fraction flipped, so it'd be 13/5. Cosine theta was adjacent over hypotenuse, so it'd be 12/13 in this case. Secant was the reciprocal of cosine, so secant theta would be 13/12. Tangent theta was opposite over adjacent, so that'd be 5/12. Therefore, cotangent, which is the reciprocal of tangent, would be 12/5. Let's say we wanted to find the value of theta. Okay, if we went into a scientific calculator and we just used one of these three ratios and the inverse function, so we could say sine inverse of 5/13. The sine inverse function takes in the ratio and gives us the angle. And if we're set on degrees, it'll give me theta in degrees. Or you could use cosine inverse of 12/13 or tangent inverse of 5/12. Okay, so if we're using our scientific calculator here, we just type 5 divided by 13 and take the sine inverse of that. So our theta is about 22.6 degrees. Let's now try to solve a triangle using trigonometric ratios. Let's say we're given this triangle and we want to find the missing sides and the angles. The missing angle is simply 70 degrees, and that's angle B, because angle A and angle B are complementary. Okay? But if I want to find these sides, little a and little b, I can make use of information that I'm given. So I can say, using the 20-degree angle, I can say B/6 is cosine 20 degrees. So B is 6 times cosine 20 degrees. And then I look up the value of cosine 20 degrees on a scientific calculator, multiply by 6 to get approximately 5.64. To find side A, I can use a sine ratio, and I say sine 60 degrees, sine 20 degrees is A/6. So A is simply 6 times sine 20 degrees. And then I go to my scientific calculator and find sine 20 degrees and multiply it by 6, and I get a value that's approximately 2.05. So I've solved two missing sides and one missing angle using trigonometry. An important point to bring up at this time is the special right triangles, the 30, 60, 90 right triangle with side ratios 1, √3, and 2, and the 45, 45, 90 isosceles right triangle with side ratios 1, 1, and √2. So let's say I've got a certain situation where I got a 30, 60, 90 right triangle adjacent to an isosceles right triangle. And let's say these share a side, of course. Then, if I know one of the sides in one triangle, I can find the rest because I can simply use the relationships between the sides of these special triangles. So let's say I know this side, this hypotenuse to be 6, and I'm trying to find the other hypotenuse. I know that the hypotenuse is twice as long as the shorter leg in a 30, 60, 90 triangle. So if this is 6, this leg is simply 3. And then since this right triangle is isosceles, I know the hypotenuse of the 45, 45, 90 right triangle is simply going to be √2 times one leg. Let's take a look at a brief application of right triangle trigonometry in real life. We talk about angles of elevation and depression, okay? An angle of depression is when you have to look down at an object and you move your head so many degrees from the horizontal. An angle of elevation is when you have to look up at an object and you move your head so many degrees from the horizontal up. Okay? So here's a question that we might want to look at and solve. Let's say you're standing on top of a building, okay, and you're looking down at your car. And let's say your angle of depression to see your car is 55 degrees. You know that your car is 20 feet away from the building and you want to find the height of the building. Okay? Angle of depression is this angle here. So we can simply say, okay, these are parallel lines. So we can simply say this is also 55 degrees. And then we can use the tangent ratio. So we can say tangent 55 degrees is h over 20. So the height of the building is simply 20 times tangent 55 degrees. We can go to our scientific calculator again and find tangent 55 degrees to be 1.428. And I plug 1.428 for tangent 55 degrees, and I find the height of the building to be 28.56 feet, approximately. In this lesson, in lesson 11, we used our trigonometric functions to find us missing lengths and angles in a triangle. We also looked at triangles with given lengths, side lengths, to find the trigonometric ratios. I hope the lesson has been useful, and I will see you in the solutions to worksheet 11.